So. Hello and welcome to today's webinar. We're just waiting 1 or 2 minutes for everybody to settle in. Okay, thanks for joining. Today we will have a look at the basic principles of flue gas cleaning with electrostatic filters, and we'll also have a glance at different particle sizes present in flue gas and how to measure them. If you have any questions, please feel free to ask them in the chat on the right side. We will answer as many of them as possible after the webinar. My colleague Morten, he will also be in the chat during the webinar and answer questions if he can, and otherwise we will collect them afterwards when we're done. So my name is Finn Hahn and I'm the new project manager for our ESP filter products. I joined Exodraft as a project manager in December 2019. I have a master's degree in product development and innovation. I'm from Germany and have been living in Denmark for 9 years. So what are we looking at? Today we will give you an overview of the basic principles of wood combustion. We'll look at what particles are, how big they are, and how we can quantify them. And we will have a look at alternative ways of measuring particles. We'll give you a brief overview of the health risks related to fine and ultrafine particles. And we will have a look at ways of removing the particles from the flue gas and a brief look at new regulations present in other countries. So very basic, this is broken down to a very basic overview of wood combustion. Basically what we do is we add wood and air and we get heat and flue gas. So today we will not focus on the wanted product from wood combustion, which is the heat, but rather look at the flue gas and what it contains. And more precise, we want to look at the wood particles, or the particles inside the flue gas. So this is what we want to look at. What are the primary emissions from wood stove combustion? As the biggest part, we have so-called primary particles, which actually start out as solid particles. This could be soot, ash, or tar particles. And then we have secondary particles, which start their life as gas and then later on condense or form during cool down in the chimney. These are called COCs or condensable organic compounds. And then we have gas emissions, which could be CO2, CO, carbon monoxide, or VOCs, volatile organic compounds. So today our focus is on particles. Here are lumps of particles under a microscope. Most of them, they are carbon particles from wood combustion. And now we want to have a bit of a perspective from the sizing criteria of particles. So a round particle sized 1 micrometer weighs approximately 1,000 times more than a particle of the size 0.1 micrometer or 100 nanometers. And a 25 nanometer particle, which is in the dangerous area health-wise, weighs around 1,000 times less than a 250 nanometer particle. So the dangerous ultrafine particles almost have no weight, and the weight is not scaling linear in respect to their size. So going from 1 micrometer to 0.1 micrometer is 100th of the size, but it's only a millionth of the weight. So here we can see that the weight factor and the size factor is quite different. So let's look at particle sizes from several different sources. We are, of course, interested in the wood stove emissions, which are here. And you can see they are in the same region as tobacco smoke and diesel emissions, actually, and also viruses for that sake. Visible smoke is made of bigger particles in 1 to 5 micrometer area, and invisible smoke is made of fine and ultrafine particles. So these are in the nanometer area. The often referred to value for fine particles is the ones called PM 2.5. These are measured in various measurement stations and referred to for fine particle emissions. But you can see the wood stove emissions actually go far further down, much further down than only PM 2.5. So, and to give you a reference again from the earlier slide, here is the 1 micrometer particle above the slide, above the chart with the sizes, and the 0.1 micrometer and 0.01 micrometer particle sizes. You can see the size distribution is actually very, very different in the area the wood stove emit. To make a statement about how severe emissions are and how to compare them, it is important to be able to quantify emissions. Today, there are two main ways of measuring particle emissions. You can see them here. On the left side, we see the more classical method, which is a gravimetric measurement method, where you pull a defined amount of flue gas through a quartz filter, and then you weigh the difference before and after to get a statement about how much particles have been emitted during a combustion process. On the right side, you see a counting method. There exist several different ways of counting particles. One is called CPC, it's a condensation particle counter, or an SMPS, which basically is a CPC with an added dimension of the particle sizes. I will talk about this in a second. And particle counting has been used in automotive emission testing for better accuracy. And since combustion and wood burning applications have been improved the last few years, we get also much more ultrafine particles. And therefore, gravimetric methods are not as useful anymore as they were. So basically, on the left side, we are weighing, and on the right side, we are counting. That's the two main differences in the way to quantify particles today. So bigger particles, they are much more relevant in the mass and therefore in the gravimetric measurement principle. Smaller particles do not add a lot to the mass, but can be very high in numbers. You can see it on the chart. The black line is the mass compared to the size, and the dotted line is the particle number compared to the size. So one big particle can actually make up for thousands of fine and ultrafine particles. Big particles are the visible ones in the smoke, and finer particles typically are invisible. So when we talk about large particles, it's particles up to PM10, and fine particles, it's up to PM2.5, and ultrafine particles, it's usually around PM0.1. So when talk about particle mass, we are weighing the mass of the particles per burned wood or per cubic feet of flue gas. This can be measured in hot or cold flue gas, depending on the standard you're measuring according to. And the gas-based particles, the secondary particles, they do not add as much to the weight as the bigger carbon particles. And when talking about particle numbers, you quantify it by a quantity of particles per cubic centimeter in the smoke or flue gas. And these can be measured in both hot and cold flue gas as well. And also in the cold flue gas, you can actually measure the condensated particles or the secondary particles. So just to be a bit more precise, when we do a gravimetric measurement, we have these quartz filters, and they will be dried and according to the standard. And there's two ways of measuring. One is to measure in diluted flue gas, which is cooled down flue gas, or we can measure directly in hot flue gas, which would be according to the DIN standard. The diluted standard is a Norwegian standard, and the hot flue gas measurement is a DIN standard. The weighing of particles on filter material is usually used in laboratories for appliance approvals or testing. There's also, you can see here, there's also mobile devices such as the black one on the right, which can be used for on-site measurement, and typically they are used by chimney sweep to approve installations or to make a yearly checkup of installations. And then, so this is the gravimetric measurement principle. For the particle counting, actually we detect each single particle, and we can again either measure in diluted flue gas according to a Norwegian standard or in hot flue gas according to a DIN standard. The detection is either done optical with laser light and a detector, or by electrical field. So particles, they get charged and they changes the behavior of the electrical field, and in that way we can detect them. The optical detectors are more precise and usually used in labs, but to make them work with these fine particles, we actually need to condense a fluid onto the particle to make them bigger. That's why they are condensing particle counters. So we, in the inlet, you can see on the right illustration, we put in the flue gas, and then we condense a liquid onto the particles to make them bigger, and then they can be counted by a laser and a detector in the particle counter. So this is the CPC principle. SMPS is another way of counting particles, and it adds the dimension of sizing to the measurement method. So it gives a distribution of the particle sizes present in a measurement cycle. With these principles, we can count every single particle in the measurement range compared to the gravimetric measurement method, where we only can weigh the count for a certain size of particles. Due to the fact that gravimetric methods not can show the amount of fine and ultrafine particles, we believe that particle counting is far superior to gravimetric measurement. So now that we know a bit more about particles, why would we want to remove them? They go quite deep into our bodies. Fine and ultrafine particles can reach deep into our lungs, and especially the ultrafine particles can even reach our bloodstream and spread inside the body. Particles can build up in several areas and cause inflammation, for example. They can lead to cardiovascular diseases, asthma, bronchitis, COPD, and the impact to the society by particle emissions, it's hard to quantify, but research has shown that people's lifespan and also money can be hit by particle emissions. What can be done today? Looking at emissions from wood-fired stoves, with an electrostatic filter, it's possible to reduce particle emissions and black carbon emissions. And a chimney fan can help with CO emissions due to better combustion, and also actually particle emissions because of a better combustions. With an electrostatic filter, we cannot reduce dioxin emissions or PAH emissions from the fire. How does it look? So here you can see on the left side we have particle accumulation after 75 minutes of fire without a particle filter, and on the right side you can see the same burning cycle with the filter enabled. On the top you see, on the left side you see the very black quartz filter, which actually shows a high amount of particle buildup. On the right side, the filter is almost clean because the electrostatic filter has been activated. So how does an electrostatic filtering principle actually work? The principle is not new. It has been used in the industry for many years. What is new is the small form factor design, which can be used by consumers and in private homes. It cleans the flue gas based on electrostatic precipitation principle. So it applies high voltage to an electrode inside the filter, creating an electrostatic field, which the flue gas passes through. You can see it in the red square here. The particles become charged as they pass by the electrode, and this charging of the particles adds horizontal accelerations to the particle. And because the particles have the opposite polarity as the inner surface of the filter, they get attracted to the surface and attached to it like a magnet, thereby filtering the particles from the flue gas. So here you can see the buildup on the outer wall. So where can electrostatic filters actually be used? Our ESP10 can be mounted on any existing stove. It must be a closed fireplace with up to 10 kilowatt of heat output. The smoke particles will travel up inside the chimney, and it actually doesn't matter what kind of chimney it is. The filter will be mounted on the outside because there the flue gas is as cold as possible, and many secondary particles already have condensed to solid particles, and it's visually matching a steel chimney pipe. Normally the filter will be in an idle state, and there's a temperature sensor inside the filter at the bottom, and when it sees an increase in temperature, it will turn on the filter. So the filter will turn on automatically shortly after the fire is lit inside the fireplace. And together with the filter, the built-in chimney fan or draft booster will turn on and make sure there's a steady draft inside the chimney. And the chimney fan will also help to reach the best possible combustion inside the fireplace. Also now the high voltage supply for the electrode is activated and the filter is working. This will give a 95% reduction in particles, and this is measured by count. When the filter is running, most of the particles are collected inside the filter. During startup, there can be some white smoke visible, which typically is water vapor from the chimney and to some degree also from the firewood. This will go away once the operating temperature is reached of the whole system. So here you can see a chimney with the filter deactivated. There's a lot of visible smoke. I believe this is the early phase of the burning process, and this is what we don't want to see. And here is the same chimney, same fire, just with the filter activated. There's almost no visible smoke. And just to make sure that you don't think we are doing some kind of trickery, here's the transition from the filter being on, and now we are turning it off. And as soon as it's off, the visible smoke will appear. You can see it once more here, filter on, and then it will be turned off in a second now, and the smoke starts to appear. So the particles are collected inside the filter. What happens to them, and where do they go? That's the question we always hear. So when the fire has burned out, the filter actually will deactivate itself, and before it's going into the standby mode again or the idle mode, the filter will run a self-cleaning cycle. This is only done if the filter has been running for more than 5 hours since the last cleaning cycle. And once the cycle is activated, it will run for about 5 to 10 seconds. And there is two ways the particle filter will deal with the particles. One way is it actually will collect the particles inside the filter, and then once the fire has burned out, oxygen will rise up through the chimney, and most of the particles actually will self-ignite. Because we have our fire triangle completed, heat, fuel, and oxygen are present inside the chimney, and therefore a big part of the particles will burn off in this way. The remaining particles will sit on an internal cleaning grid, and during the cleaning cycles, these particles mechanically will be removed from the grid and fall back into the chimney. These particles will either return to the stove and burn up during the next firing cycle, or they will collect at the bottom of the chimney and can be removed by a chimney sweep. So here are some key figures about the ESP10 particle filter. It has a patent pending key functionality on several areas. We have a high efficiency of removing particle mass. Remember, this is the gravimetric way of stating how many particles we emit. It has a very high efficiency on particle count. Over 95% of the particles are removed by numbers. And it's especially effective on the fine and ultrafine particles, which are the ones that have a health risk connected to them. It has a self-cleaning functionality to keep up the high efficiency with low maintenance needed. It has a unique electrode design which enables the high efficiency, and it has an easy 230-volt plug-and-play connection. The filter will always be mounted as the last element in the chimney to have it at the coldest place. It's tested and approved by German DIBT, which does check of building materials, and the effectiveness has been approved by RRF, which actually is a testing facility for firing places. And we have run some field tests during the last 2 firing seasons with great effect. So lastly, I want to give you a quick overview of what's happening regarding regulations. Germany has released the Blue Angel for wood burning stoves in December 2019. For now, it's a voluntary regulation, just as we have the Nordic Swan in Scandinavia, or Germany has this Blue Angel. And the Berlin area wants to make it mandatory for new installations. And there's a big discussion about standardized measuring methods, because today the only standardized method is a gravimetric method, but this one, it's hard to quantify fine and ultrafine particles with this measuring method. The Blue Angel is supported by environmental organizations in Germany, and it is actually the first regulation which takes the particle count into consideration, which is very interesting. So, thanks for watching. We have a few sites where we present our new filter product. These will also be mentioned in the descriptions. And all the sites have a FAQ located on them, which answers many of the frequently asked questions, and it's very good to have a look at that. And regarding prices, our end user sales prices will vary from country to country, so please contact us after the webinar if you have questions regarding pricing. So I think now we will start to have a look at eventual questions that might have come up. No questions. All right. Then I think we will end it here. Thanks for joining the webinar. And if you have any questions, please feel free to contact us on all the possible ways present at our websites. Thanks for watching and have a nice day. Bye-bye.